Good afternoon. I hope you've all had a great day. Before we start, I want to say that I am slightly nervous, so please bear with me. So, I'm Siobhan Stevens, and I work as a software developer at Mobilize Cloud. I'm currently in my second year of studying a degree apprenticeship in software engineering at the University of Wales Trinity St David. And today I'm going to talk to you about how we're using serverless to help generation rent. So I'm going to start by showing you a short video from the founder of TenantFootprint, Mark Evans, who will tell you what it's all about.
Hi, my name is Mark Evans, and I'm the founder of TenantFootprint. Today, we wanted to give you another real-world example of how serverless technology is being utilized to make an impact on people's lives. At TenantFootprint, we're trying to tackle two of the biggest problems in the UK housing industry. Firstly, the struggle that first-time buyers face in trying to get onto the property ladder, and the biggest barrier being the large deposit required by lenders. And secondly, social discrimination, and the discrimination faced by those social tenants who have been forced into the private rented sector due to a shortfall in social housing. To overcome both of these issues, TenantFootprint utilizes open banking to track rental payments and help build an individual's credit score. Hi, my name's Mark.
Not again. So, now you know what it's about, let's discuss how it works. TenantFootprint is built using HTML, CSS, JavaScript, jQuery, Ajax, and Bootstrap for the client side, along with PHP for the web server. The PHP is used to call API gateways, which trigger serverless Python Lambda functions, where most of our processing takes place. The web server is on Elastic Beanstalk, or EC2, and an RDS MySQL database is used on the back end, all of which is deployed via Terraform using Mobilize's GitLab CI/CD tool. Further to this, we have added DevSecOps to our serverless project by using SonarQube to check our code quality and automated testing after deployment. We use Cognito for secure user authentication and management, such as sign-up, login, and account recovery flows. This enabled us to focus on building the core functionality of the app without worrying about reinventing the wheel with user management, and of course, saved us lots of time. So, with the main function of the app being to allow renters to have their rent payments count towards their credit score, we had to have access to their bank account transactions. And so from day one, we had to make sure that the system was secure. For this, we use TrueLayer, which provides a simple and secure API for open banking and allows us to access the account transactions using secure tokens. Our system then processes these transactions to identify rent payments and sends the data to our partner Equifax so that your rent payments can count towards your credit score. These processes are triggered using daily CloudWatch events. When processing these transactions, we use SQS queues to allow for parallel processing so that we can increase throughput and process thousands of tenancy payments simultaneously. Any unsuccessful payments are written to a dead letter queue where they are later retried or handled accordingly. So the application was built with the AWS well-architected framework in mind. Operational excellence. We have well-defined processes with fallback methods and use monitoring tools such as Epsagon to continually monitor for failures and SonarQube to check that our code is up to standard. Security. Here, best practice has been implemented from using an encrypted RDS database, encryption at rest across all data storage services, along with using HTTPS connections and least privilege security rules. Reliability. We've used scalable lambdas to allow the app to respond to demand whilst remaining reliable. Performance efficiency. The parallel processing capabilities of the SQS queues allow us to process thousands of transactions efficiently. Cost optimization. We've used only the necessary size instances and continually check for redundant functions. And by using the serverless framework and Lambda functions, this has enabled us to forego having multiple instances on 24/7, with the majority of the app being on demand. So, why serverless? With its low entry level and cost, speed and reliability, it allows me as a developer to focus on what really matters. Let's break it down a little bit. So the main advantage of serverless to me was that when I started working at Mobilize and working on the project, I had no experience of infrastructure, networking, provisioning servers. I only had experience of writing code. I hadn't even really heard about serverless. However, after reading into AWS and the serverless framework, I was quickly able to start writing code and deploying functions without worrying about the complexities of networking, allowing our resident cloud engineers to work in peace without giving me endless 101s. The serverless framework allows me to quickly deploy code to multiple environments, provision APIs, Lambda functions, and S3 buckets, all with only a few lines of code. The simplicity is key. Now, further down the line, to improve the development process, we have implemented automated deployments through a GitLab CI/CD pipeline, along with multiple quality checking tools, such as the previously mentioned Sonar Cube, along with TruffleHog, which allows secrets to remain as secrets, and retire.js to ensure we aren't adding vulnerable libraries to our code. As mentioned, we also use Epsagon to continually monitor for failures and quickly spot issues before we go live. We've also recently added the serverless warm-up plugin to our most commonly used Lambdas, which eradicates the cold start issue for only a few extra dollars per year. On a final note then, from my personal experience as a student, serverless isn't taught or even mentioned, really, at school, college, or university. The cloud platforms that we all use are also hardly mentioned, however, are an integral part of industry. I use serverless technologies wherever possible in my university assignments, from using basic Lambdas, API gateways, and S3 buckets for hosting, which allows my work to remain as industry-like as possible, allows me to continue to learn, and also makes things much easier. I always try to educate my fellow students on the advantages of serverless because it's not only the future, it's relevant right now. So, thank you for listening. If you have any questions, come and find me later. Nice and short and sweet.